So problem 7.1, let f and g be differentiable in R, okay, so that we don't need to worry about them not being differentiable at some points. Write down the derivative of the following functions in their domains, okay. So this is basically, it's going to be an application of the chain rule so that you get used to it if you're not already familiar with it. Okay, the first one is h of x is the square root of f x squared plus g x squared, right? So this is the square root composed with this, okay, which at the same time is the composition of these two functions squared, right? So the derivative of h of x is going to be the derivative of the root, okay? The derivative of the root is 1 divided by 2 the square root of x, okay? So this is going to be 1 divided by 2 the square root of this f x squared plus gx squared, okay? And then times, okay, this is the derivative of the first part, and then the derivative of the argument, okay? And now the derivative of the argument is going to be the derivative of this first factor, and again this is a composition, so this is 2 times the derivative of x squared is 2x, okay, so this is 2 times f of x times the derivative of x, and the same times with g, 2 times g times the derivative of g. Now if we do some simplifications of the 2's, you get f prime at x times f at x plus g prime at x times g at x divided by the square root of x f squared plus g squared. Okay. This is the derivative that we're searching for. Okay. Next, part 2. H is the arctangent of f divided by g. Now the derivative of the arctangent is 1 divided by 1 plus x squared, so the derivative of h is going to be 1 plus, divided by 1 plus this argument squared, right? This is the chain rule. Now times the derivative of this, okay? The derivative of this is going to be g, this is the derivative of the quotient, right? This is g squared, and then f prime times g minus f times g prime, right? Now this is doing some algebra, you get f prime at g times g minus f times g prime, right? And in the denominator we get gx squared is multiplying here, gx squared, well, you get gx squared plus, and then gx squared multiplying this, so gx squared in the denominator and numerator cancel out, so you have f of x squared, and this is the derivative that we're looking for. Okay, let's do 3. H of x is f at g times f e to the f. Okay, so we have to apply the product rule and the chain rule at the same time. Okay, so we have h prime is going to be, first, the derivative of the first factor is going to be f prime evaluated at g times g prime, right, times the other function without differentiating, and then now times f at g times f prime at x, because that's the differentiable, the derivative of this second factor. Okay, it's just straight application of the product and chain rules. Okay. 4. H at x is the log of g of x sine of f of x. Okay, this is going to take longer because of this is the application of the chain rule in in chain, right? In string. But wait a minute, this is easier because this is the logarithm of the product, so you have the logarithm of g of x plus the logarithm of the sine, so we don't we get rid of using one of the product rules, right? So we have the logarithm of g of x is g prime divided by g, okay? And then the logarithm of the sine is the cosine of f divided by the sine of f times the derivative of f, right? And then this is the cotangent of f of x, okay? So this is the derivative, straight application of the chain rule again. So now 5, we have h is f to the g. Well, in order to do this, we need to write this like this. This is e to the g log of f, okay? Because otherwise we don't, we're gonna mess up, okay? And now the derivative of this is the derivative of the exponent of this, so this is g prime times the logarithm, right? Plus g times g f prime divided by f, which is the derivative of the logarithm of x. All of this that multiplies e to the g logarithm of, okay? Which you could rewrite as f to the g, right? Okay? And then part 6 is going to be h is 1 over the logarithm of f plus g squared. Okay? So this is the derivative of a quotient, right? So this is the, first of all, the logarithm of f plus g squared, okay, all of this squared, and then what we have is the derivative of the of the numerator, which is 0, and then minus the derivative of the denominator times 1, okay? So then we have the derivative of this, which is first of all f plus g of x squared to the minus 1, okay? So 1 over that times the derivative of this, okay, which is f prime plus 2 times g prime. Okay, that is the derivative that we were looking for.